Good morning, this is Ms. Billerbeck, and we are going to talk about 10.2, the cube root function. So f of x equals the cube root of x, and this is its graph. So our key points on this graph, again, we have 0, 0. This one, again, 1, 1. But this is unusual. We have -1, 1. Oops, -1, -1, excuse me. And then out here, we have 8, 2, but then down here, we have -8, -2. So the cube root function is a really interesting one, and it makes a beautiful curve. So let's take a look at this with Cahoots, or not Cahoots. Oh, I wish we could play Cahoots right now. Let's look at this with Desmos. All right, whoops. Where did that go? Sorry about that. Okay, so we have a cube root function now. Instead of the actual cube root, I'm making a grouping symbol and doing an exponent of 1/3, which is the exact same thing as a cube root. So just like a square root, the exponent would be a 1/2. A cube root, the exponent would be a 1/3. So if we see, it's the same situation as the square root, where we had the a here, the b associated with the x, the h here, and then the k here. And it does, everything is the same. This is kind of cool though. So this is the reflection about the x-axis. Woo, I can make you dizzy. Boom. Okay, whoops. Didn't mean to do that. But anyway, let's move it back to 1. There we go. All right, so if I make it -1, I lost my slider sadly. If I make it a -1, you see it just makes it across, it reflects it across the x-axis, just like we would expect for any graph. Okay, the p, well, it was a horizontal stretch or vertical compression when it was a fraction. Let's see, yes, it does the same thing. See how it's getting closer to the x when it's a fraction? Okay, and so then as it gets larger, it moves farther away from the x. So that becomes a horizontal compression. It's compressing away from the x. Okay, so again, when the variable is close, the coefficient of x is in the grouping symbol, it tends to associate it with how is it affecting its relationship with the x-axis, as opposed to if it was outside the grouping symbol. So let's go back to this. And then h, of course, it's the exact same thing. It's been the whole year. When x is greater than 0, it moves to the right. When x is less than 0, it moves to the left. So no surprises there. And the k is exactly the same. When k is positive, it moves up. When k is negative, it moves down. Okay, so with that in mind, now we can go back and look at some of our examples. So what are the maximum and minimum values of the cube root of x over the interval of -27 to +27? So if we did f of 27 and we have the cube root of 27, well, that's the cube root of 3 times 3 times 3. So that's just 3. And f of -27 is the cube root of negative 27, which is the cube root of negative 3 times negative 3 times negative 3. And that's just negative 3. So 3 negatives make a negative, 2 negatives make a positive, even number of negatives make it positive, odd number of negatives make a negative, okay? So we'll take it to the next level since you're about to graduate from Algebra 1. All right, so we just see that, well, if this is the domain, the range then will range from negative 3 is less than or equal to y is less than or equal to 3. So our minimum would be here, and our maximum would be here. Okay, so we could write that as a coordinate too if we really wanted to be to do so. So it'd be negative 27, negative 3, and then the max would be 27, 3. So there we have it. So let's compare the parent graph. This is the parent graph here. So this one's just vertically shifted down 2. Two units. And this one here, oh, this is an H and it's hiding. This one is hiding its x minus negative 1. So that's a negative H. So this is horizontally shifted left 1 unit. Okay, so remember the H is tricky. If it's a plus sign, that means it's a minus a negative number. Okay, so now we're going to look at a cube has a volume of 10 centimeters cubed. A larger cube has a volume of x centimeters cubed. Okay, so what that means, okay, so if I have a cube, and it's x centimeters cubed, that means this is the cube root of x, this is the cube root of x, and this is the cube root of x. So it means all these sides are the cube root of x, because the cube root of x, I'm going to go a step further, cubed is x to the 3 over 3, which is x to the 1, which is x. So for this to be x, then these all have to be cube roots because volume is length times width times height. So we had to have 3 sides to make volume. So that means we have cube root sides. Okay, so with that in mind, now let's look at this formula that we're coming up with here. So we have this formula here. So we have f of x equals the cube root of the larger cube minus the smaller cube. So if this one's 10, then that's the cube root of 10 for each side, okay? So when we have this in here, x minus 10, that's the difference in the volumes of the 2 cubes. So when we have this, this means the difference of the sides. Okay, so now we know what this formula means. So if we look at f of 14, and we do the cube root of 14 minus 10, that's going to give us the cube root of 4. And that'll be, we're dealing with centimeters, so the units are going to be centimeters. So that's the difference in the sides of the two cubes when this cube is 14 centimeters cubed. Okay, so then f of 19 would then be 3 times the square root of 9, or cube root of 19 minus 10 equals the cube root of 9 centimeters. So that's the difference of the two cubes when the larger cube is 19 centimeters squared versus 10 centimeters squared. So the difference in the two sides is the cube root of 9 centimeters. All right. So let's compare the average rates of change for f of x equals 2 times the cube root of x minus 3 over these intervals. So first we need to look at, well, what is f of negative 12? So we have 2 and we have the cube root of negative 12 minus 3. So 2 times the cube root of negative 15. Sadly, that is not a perfect cube. Okay, so this might be a good idea to use a calculator. So 2 times, and that's negative 15, and that will be a 1/3 exponent. Is easy enough to use. So we have negative 4.93. Okay, so then f of negative 8 equals 2 times the cube root of negative 8 minus 3 equals 2 times the cube root of negative 11. So now let me find that. So negative 11. So that one equals negative 4.45. Okay, so now let's look at f of negative 4 equals 2 times the cube root of negative 4 minus 3 equals 2 times the cube root of negative 7. And that's negative 3.83. And then we have f of 0, which is 2 times the cube root of 0 minus 3, which is 2 times the cube root of negative 3. So that gives us negative 2.88. All right, so for the first one, let's do M1 for interval 1 is this one, and interval 2 will be that. So we're going to take 8, so negative 4.45 minus the 12, so negative, and that's 2 negatives, negative 4.93 over negative 8 minus negative 12. All right, so let's do that quickly. I am going to use my calculator right now, so please excuse me. So 4.93, and then I'm going to divide by 4. Okay, so that gives me 0.12. And then M2, I have start with the 0. So that's negative 2.88 minus a negative 3.83. And that's 0 minus a negative 4. So the intervals are equal. They're both 4 different. So let's look at what this one is. Okay, so this one ends up 0.24. So this one has the greater change, or greater delta, we can say. All right, so let's take a look at, that's close to, remember when we had this? Whoops, not this, wrong function. That's the square root function. There's the function. So we're talking about this area here. So we have, this is shifted right 3 to right here. Okay, so now we have that shifted off here. So these values in negative 12 and the negative 12, negative 8 are very far along on this curve. And 0 and negative 4, if we have the new point of inflection, this is called the point of inflection. So the new point of inflection is now moved 3 over. So 0, negative 4 would be more in this area. It's still changing more than way over here. Okay, but that's what we're seeing. It's not changing a lot, but it is changing. So this area, interval 2, is changing a little teeny bit more. All right. So which function has a greater average rate of change for the interval -5 is less than x is less than 0? The translation of fx to the right 1 unit and up 2 units, or the function r of x that is just shifted up. Okay, so let's just make a quick graph of what we're looking at. Okay, so it's basically the parent function, but it's shifted. So this one shifted right 1 and up 2. So we have something that's looking like this. Okay, so that one is f of x. And the next one is just shifted this direction. Oh no, that's shifted up. So that one shifted up, so it's like this. So now we are looking at this interval between 0 and -5. 1, 2, 3, 4, 5. So this interval, which one's changing the most? So this is g or r of x right here and f of x. So we see that the inflection point of r of x is in this interval. So we're catching the inflection point and this big change right here versus this one, the inflection point's here. So a lot of the changes already happened before we got to 0. So r of x changes more in that interval. All right, that's it. So I hope you have a wonderful day. Bye-bye.